everyone, this is Mayank. Welcome back to a new system design video. In this video, we are going to discuss the various key characteristics of a distributed system. So let's begin. There are basically 5 different key characteristics of any distributed system. The first being scalability. Then, a distributed system needs to be reliable so that it's able to handle the traffic at any given point in time. A distributed system needs to be highly available. A distributed system needs to be efficient in terms of performance. And a distributed system needs to be manageable so that at any given point in time, if there is any incident that happens with your software or your hardware, you're able to bring your system back to normalcy and it's able to handle the load back. So with these 5 key characteristics, let's deep dive into each one of these individually. So let's talk about scalability. Now, scalability can be defined as the capability for a system to handle load as and when it grows. So let's say you start with a service that is having a user base of 1 million, and then it slowly and gradually becomes popular and you now are serving a traffic which is close to 1 billion. So your service needs to scale well as and when your user base increases and your traffic to your website or to your service increases. Now the scalability could be in terms of increasing the number of instances. So there is basically horizontal scaling, and then there is vertical scaling, wherein, because assume that you have a very small service that you're running which converts a text file to a PDF, and you don't want it to horizontally scale because you're working with a very small customer base. And even when that customer base increases, you can always do vertical scaling. So you can vertically scale your application by replacing that existing server with a more powerful machine. So it has more CPU, more RAM, more storage, more compute basically. So that's what the vertical scaling is. So you could horizontally scale your application, you could vertically scale your application to ensure that as and when the number of requests, the number of transactions, or the data volume that's coming to your application increases, you are able to handle that load. So that's basically scalability. Now let's move on to reliability. So reliability can be defined as the probability for a system to fail. So let's assume that you have a distributed system and it's performing well over a considerable amount of time. So now at any given point in time, if one or multiple failures happen with respect to your software or with respect to the application that you're running or the hardware on which your application is being run, if there is any failure in any one of the components, if despite that failure, if your service is able to handle the requests well, then your distributed system is considered as reliable. Let's take an example. So assume that you are operating a big commerce website and there are user transactions happening almost every second. And one of the transactions is where a user adds something to their cart. Now, if that request is handled by a server V1, and if that server goes down because of power socket failure or any other reason, then despite that, if you're not canceling the transaction and that particular transaction is handled by a different server within your cluster of servers or within your infrastructure, then your system is considered as a reliable system. So at any given point in time, if the requests coming to your system are handled despite the failure of the infrastructure, whether it's a software or a hardware failure, if you're able to handle that particular service, then it's basically considered as a reliable system. Whenever you want to have a reliable system, you're going to have redundancy implemented, which would mean you have multiple servers which could be used as backup if at all the primary instance goes down. So there's going to be additional cost that you will have to incur every time you want to have a reliable system, because you're bringing in redundancy into your infrastructure and your setup. So it's going to incur cost. Now let's move on to availability. So a system is termed as available if it can remain operational over a period of time. The difference between a system being reliable and a system being available is the fact that a system can be available, but it's no guarantee that it will be reliable. And if a system is reliable, it is always a guarantee that it's available. Let's understand that with an example. So let's assume that you have a service that incurs a downtime of 1 hour after every 24 hours of it being operational. Now, if that's the case, then the system can be termed as available for the 24-hour duration, but for that 1 hour duration where it has to incur a downtime, it's no longer available, and hence it can't be termed as a reliable system. Whereas you have another system that can remain operational throughout the day, and you don't have to incur any downtime in order for that particular server or service to be operational. And that's where the system can be termed as reliable, because it does not need to incur any downtime. So a system which is reliable has to be available, but a system which is available has no guarantee that it can be reliable. Now let's move on to efficiency. Now, talking about a distributed system being efficient, it can be measured in terms of latency and throughput. Latency is basically how long the server or the system is taking to respond to a particular request. That's basically defined as latency. And then the second bit is throughput, how many number of requests that the system can handle. So a distributed system needs to be efficient in terms of how much time it's taking, how long it's taking to respond to one request, and then how many requests it can process in a specific stipulated amount of time. So that's basically the two key attributes that are used to define whether a system is efficient or not. Now, last but not the least, a distributed system needs to be manageable. When I talk about manageability of a distributed system, it means if there is any incident, if the requests have started to fall apart, wherein there are no longer 200 OK responses coming from that particular server, and it is down because of memory issues, or because the requests are getting timeout, or because it's power socket failure, then how quickly can you respond to that, and how quickly can you fix your service so that it's back online and it's back operational? That's something wherein your runbooks would come into play, where you need to have proper SOPs defined for each particular service and each particular incident as to how to handle to it and how to cater to it. Let's say there is a security risk that needs a hotfix to be deployed to production. How quickly can you get that particular change out into production? You need to have proper CI/CD in place so that any change that needs to be pushed out to production, that can be done in the minimum time possible. So that's where you need to have proper runbooks in place, proper SOPs defined, have proper CI/CDs in place to ensure that you are able to manage your service well. When we talk about the operational aspect of it, any distributed system which is running online needs to have proper alarming in place, so that at any given point in time, if there are drop in the number of requests getting processed successfully, you are able to look at the metrics and figure out where the root cause is, and diagnose the root cause. So those are some of the methodologies that you could implement in order to ensure that your system is manageable. So we've talked about metrics and monitoring. We have talked about SOPs. We have talked about runbooks. And these are typically what you would find in any distributed system running online. So companies like Amazon, Facebook, they all have different services running, and they all those services have their runbooks, SOPs, metrics, thresholds defined, and alarmings in place to ensure that at any given point in time, if there is an instance or an incident which brings down the availability or the efficiency of a system, they are able to follow those SOPs and runbooks to ensure that they bring the system back online. So yeah, that's all about it in this video, where we discussed the key characteristics of this distributed system. We talked about scalability. We talked about a system being reliable, available, the difference between reliability and availability for a distributed system, how to determine whether a distributed system is efficient, and then how to manage a distributed system. So yeah, that's it for this video, guys. Thanks for watching.